This is a video from section 3.6. Recall. If y equals b to the x, then dy dx is equal to b to the x times natural log of b. Note, b is greater than 0 and b does not equal 1. Now, what we're going to do is we're going to use that idea to find the derivative of log of x with base b. So in other words, we're going to set y equal to log base b of x. And we want to find dy dx. Okay? Now, what this says is b to the y is equal to x. Now we want to differentiate both sides with respect to x. Oh, no we. And we're going to use implicit differentiation. So I'm going to take d dx of b to the y, and I'm going to set that equal to d dx of x. So b to the y times natural log of b times dy dx. That's equal to 1. Now, solve for dy dx. Okay? And what that says is dy dx is 1 over b to the y times natural log of b. Right? So I just divided both sides by b to the y natural log of b. But remember, b to the y is equal to x. And so therefore, dy dx is 1 over x times ln of b. And so therefore, this is what we can say. d dx of log base b of x is 1 over x times natural log of b. And I'm going to give you a special case of this result shortly. Okay, so this is our first formula. Okay, now set b equal to e. And then what we want to do is we want to figure out the derivative of log base e of x. Now there's another way to write that, which we will do in just a minute. Okay? Now this is 1 over x. Now remember, I'm replacing b with e. And so I'm going to take 1 over x times natural log of e, right? But remember that the natural log of e is 1. And so this is just 1 over x. And note, log base e of x is the same as natural log of x, right? ln of x. And so therefore, we can say the derivative of ln of x is the same as 1 over x. So this is just a special case of the previous result. And what I want to do is do some examples that involve the derivative of the natural log. And so we're going to differentiate the function. And so let's take a look at example 1. Suppose I'm giving you the following. G of t is the same as natural log of 3 plus t squared. So if I take the derivative, of the natural log, I'm going to get 1 over the stuff inside, which is 3 plus t squared. But by the chain rule, you want to multiply by the derivative of the inside function. The inside function is 3 plus t squared. Okay? And so this is 1 over 3 plus t squared multiplied by 2t. Okay, because remember that the derivative of a constant is 0. So therefore, g prime of t is the same as 2t divided by 3 plus t squared. And that's number 1. Example 2. Suppose I had this. G of t equal to we'll do this one. Natural log of x e to the negative 2x. Oh, let me make that an x so the argument matches. And so if I want g prime of x, I'm going to take 1 over x e to the negative 2x, right? And I'm going to multiply by the derivative of the inside function, which is the derivative of x e to the negative 2x. So this is chain rule. So therefore, g prime of x is 1 over x e to the negative 2x times. I'm going to take the derivative of the first, which is 1, times e to the negative 2x plus x, and then I'm going to multiply by the derivative of the second function. The derivative of the second function is negative 2e to the negative 2x. Okay, so that's just chain rule. But if you notice, an e to the negative 2x is common to both, right? So I'm going to factor that guy out. And when I do, I get e to the negative 2x over x e to the negative 2x. And I'm going to multiply by 1 minus 2x. But the e to the negative 2x's cancel. Okay? And so g prime of x is 1 minus 2x divided by x. And that would be the derivative. Let's take a look at example 3. Suppose I had this one. Log base 10 of secant x. Well, it's got to be equal to something, right? So let's do this. Suppose f of x is log base 10 of secant x. Now, if we go back, remember that this is 1 over x times the natural log of b, and that's the derivative of log base b of x, right? Now, so I'm going to do this. So f prime of x is 1 over. Now, instead of 1 over x natural log of 10, it's going to be 1 over secant x times natural log of the base. The base is 10, so it's natural log of 10. But by the chain rule, remember that we have to multiply by the derivative of secant x. So f prime of x is 1 over secant x times natural log of 10 times secant x tangent x. But the secant x's cancel, right? And so here, that says that f prime of x is equal to tangent x divided by natural log of 10. And that's example 3. Let's take a look at example 4. Well, suppose I had this. Suppose that y equals, we could do this one. How about log base 2 of x times log base 5 of x. Now, when you do a problem like this, you just want to be very careful when you go through, right? So if I want the derivative, okay, I'm going to take 1 divided by, instead of an x, it's going to be x times log base 5 of x. So I'm going to write x times log with base 5 of x times natural log of 2, right? Because the base is 2. But remember, by the chain rule, you have to multiply by the derivative of x times log base 5 of x. Okay? Now, let's write that on the next page. So y prime is 1 over x times log base 5 of x times natural log of 2. Times d dx of, and then we have x times log base 5 of x. Now, I'm going to apply the product rule to take the derivative of that piece. And so we get 1 over x times log base 5 of x times natural log of 2 times. Now, the derivative of x is 1. So I'm going to write 1 times log base 5 of x. Then I'm going to add. And then I'm going to take x and I'm going to multiply by 1 over x times natural log of 5. That's how you apply the differentiation rule for taking the derivative with log base 5 of x, okay? Now, these x's cancel, okay? And so what I'm going to do is I'm going to write 1 over, now to make this look a little cleaner, I'm going to write the natural log of 2 first, and then I'm going to write log base 5 of x second, and then if I get a common denominator, the common denominator is natural log of 5, and then in the numerator, I'm going to write natural log of 5 times log base 5 of x, and then I'm going to add 1. And that would be the derivative, right? And your teacher might want you to multiply that out a little bit. So I could even write it like this. I could say y prime is, now in the numerator, I have natural log of 5 times log base 5 of x plus 1. And in the denominator, I have natural log of 5. So x times natural log of 5 times natural log of 2 times, and then I have log base 5 of x. So the problem is involved, but you have to take it one step at a time. And let's do one more example. So this was example 4. We'll look at example 5 for this video. Suppose I had this one. Suppose I had y equals natural log of x plus square root of x squared plus 1. Okay? And I want to take the derivative there. So we're going to do dy dx, and we're going to go 1 over x plus the square root of x squared plus 1 times the derivative of x plus the square root of x squared plus 1. So this is just chain rule. Okay? Now, let's write that on the next page. dy dx is 1 over x plus the square root of x squared plus 1 times d dx of x plus the square root of x squared plus 1. And so this is 1 over x plus the square root of x squared plus 1 times, now, if I apply the chain rule, I get 1 plus, now, I'm going to come over here to the bottom, x squared plus 1, in fact, let's do it on the next page. So I'm going to say the square root of x squared plus 1 is x squared plus 1 to the half. So you want to be thinking this, okay? And so when I go back, I'm going to write 1/2 of x squared plus 1 to the negative a half times 2x. So the 2x comes from the derivative of the inside function. All right? Now, the 2's cancel. And so this is 1 over x plus the square root of x squared plus 1. This is being multiplied by 1 plus x times x squared plus 1 to the negative a half. Okay? Now let's keep going. So this is 1 over x plus the square root of x squared plus 1 times 1 plus x over the square root of x squared plus 1. So it looks like this. But what we want to do is we want to get a common denominator. The common denominator is square root of x squared plus 1. Okay? And so this is 1 over x plus the square root of x squared plus 1. Okay? Now, this is being multiplied by square root of x squared plus 1 over square root of x squared plus 1. That's just a fancy way to write 1 plus x over the square root of x squared plus 1. And so this is 1 over x plus the square root of x squared plus 1 times x plus the square root of x squared plus 1 divided by the square root of x squared plus 1. So I just got a common denominator, okay? And so if you notice, these guys cancel. And so therefore, I have dy dx is 1 over the square root of x squared plus 1. And so therefore, d dx, right? So in other words, the derivative of natural log of x plus the square root of x squared plus 1 ended up being, after all that work, 1 over the square root of x squared plus 1. And that'll conclude this video for section 3.6. We derived the derivative of the logarithm, right? We did a special case where we derived the derivative of the natural log of x, and then we did 5 additional examples. So, okay, thank you.